and welcome to A Piece of String, the show that brings together comedians and scientific minds to ask and maybe answer the biggest of all questions ever. I'm Matthew Shribman, I'm a chemist, and some might say a biophysicist. And with me today are Josie Peters, an astrophysicist.
Oh, hello there.
Paul Stubley, a laser physicist.
Hello.
And James Hay, an epidemiologist.
Good day.
Each of us will ask you questions which one of us secretly knows the answer, and points will be allocated on a arbitrary basis by our producer, Sam Lee. The winner will get the remains of the cupcake that is in my mouth, kind of in the bit between my cheek and my teeth. And that's the prize. Josie.
Hello.
Give us that sweet question of yours.
Ooh, it's a big one this week. What material would Mount Everest need to be made of for it to be a safe but thrilling slide?
Thrilling. Okay, so like thrilling in the way that a roller coaster is thrilling, but safe.
Yeah, that like you have a fun time, because if it was just sort of a slide made of carpet, I mean, you get like carpet burn anyway. But
That'd be
also,
thrilling.
if it was that long, it wouldn't be fun, would it? Unless there was some sort of soundtrack or demonstration or dance piece as you went down.
So I was having a think about this and wondering whether it would already make a safe but thrilling slide.
Is Everest safe?
You may already know the answer to this one, but it turns out that someone has skied down it.
Really?
So a gentleman called Yuichiro Miura became the first person, and I believe the only person, but I could only see a citation of him as the first person. They wanted to keep their options open. To ski down Mount Everest in the 1970s. He descended over 4,000 vertical feet, and it was the subject of a documentary called The Man Who Skied Down Everest. He was actually
very explanatory.
Yeah, exactly. So he used several items that
documentary about
people might not traditionally associate with skiing, such as a parachute to slow himself down as he was skiing down and things like this to try and keep himself under control. But essentially, no, it is not a safe but thrilling slide, and it was a very dangerous expedition.
Why is Teflon so slidey?
What's Teflon again?
Teflon's, the non-stick stuff that you get on frying pans and things.
Oh.
I'm asking this. I mean, I know the answer.
Oh, you do? What?
Shouldn't really be.
Is it? Well, okay. Is it? I'm going to humour you. Is it properties of the material, or is it like electrostatic properties or something? Like, does it repel everything that tries to touch it?
Both.
Both?
Yeah.
Is it made of beaver skin?
No. Yes? I don't think so. I don't know in a huge amount of depth. I just know that Teflon has loads of fluorine atoms just sticking up, and the fluorine atoms repel water molecules.
Wow.
Ah.
I wonder if that's
But and
similar
also
to
oil then, yeah.
And oil.
unusual. I wonder if that's similar to hydrophobic windscreens that don't need windscreen wipers or
Or like when you
That's
try
really cool,
and
isn't it?
wash a broccoli. I don't know if anyone else has tried to do this recently, but
It's literally impossible.
I
You always
I
do
wash
that.
I started to wash all my vegetables when there was that outbreak in salad a couple of years ago of E. coli on Rocket or whatever.
I thought it was an outbreak of salad.
Salad popping up everywhere. But ever since then, I've been more cautious about washing my fruit and veg, and then realizing the other day, washing a broccoli and being like, "Wow, yeah, water doesn't stick."
Maybe they should use that.
Just
Maybe
have
there's a
loads of
property.
broccolis on your car.
Actually, yeah, it would be quite
Broccoli
difficult
screen.
Broccoli
difficult
screen,
to
yeah.
see through.
Line all your frying pans with broccoli.
That's what I do anyway. I eat it, most days.
I do like it. It's nice. Lots of vitamin C.
Did anyone research a little answer to this?
I've got something for this.
Oh, yeah.
Yeah. So I was thinking about this from the point of view of how much energy you would have at the top of the mountain and how much energy you would have at the bottom of the mountain. If you just slid down it, you would end up at the bottom of the mountain with a lot more energy than at the top, and that would usually manifest into bashing into something on the way down.
Have a lot of kinetic energy.
Exactly.
A lot of movement. Yeah.
Get heated up, would you?
So if you took yourself to the top of Mount Everest, you would have 6 million joules of potential energy. 6 million.
Is that a lot?
It's roughly the same amount of energy as in a tub of Ben and Jerry's.
6 million
So that's
joules.
all you need for the whole
It
expedition.
works out at 1,400 calories.
Oh my goodness.
Or kilocalories, but in modern parlance, just calories.
So are we meant to be impressed or just like that's not many calories?
I don't think that's many calories at all.
Yeah.
But it shows how inefficient human bodies are at using energy in a productive manner. Because
To get ourselves high up.
exactly,
Yeah.
because I'm pretty sure that expeditions up Mount Everest take more than a can of than a tub of Ben and Jerry's. However, you could argue that it would be the perfect food, given that it's one of the only expeditions you would go on where it wouldn't melt.
It's quite pleasing that a whole tub of Ben and Jerry's is less than your RDA of calories or energy intake, isn't it? I can have Ben and Jerry's and a sandwich. Yeah.
So if we think about wanting to get rid of this energy that we've built up all the way to the top, you can actually just work it out with mechanics. It's actually a very pleasing little calculation because quite a lot of the parts of the calculation just cancel out. Imagine this: the height of the mountain. The higher the mountain, the more energy you have at the top.
Yep.
But the higher the mountain, the more distance you have to create friction on the way back down.
Yep.
So the height of the mountain cancels out.
So you could have a mountain that was just 0 tall and you get the same result.
Essentially.
Wow.
The mass of the human. If you are heavier, you'll have more energy at the top. But if you're heavier, you create more friction with the ground on the way back down. So they cancel out. And what you end up with is that you will need a material or two materials rubbing against each other that have a so-called coefficient of friction of about 1. Now, that is a pleasing answer, you have to admit.
Pleasing, yeah.
What does this mean?
What has a coefficient of friction of 1?
Well, how about wood on ice? Back to the skiing, or a sledge. So if we want a coefficient of friction of about 1 to use up all this energy on the way down, so we don't bash into the bottom of the mountain at hurtling breakneck speed, wood on ice only has a 20th of the friction that we need. So you would only burn 5% of that energy that you'd worked up all the way up.
I was going to say that sounded slippery and scary.
And you'd arrive at the bottom with kinetic energy of 95% of a tub of Ben and Jerry's.
You'd be sad about that, wouldn't you?
Which would be lethal, sadly. Wood on brick. If Mount Everest was made of bricks and you went down on a sledge, still not enough friction.
What?
Only 60% of the amount of friction you need. Aluminium on aluminium. Metal on metal. A mountain made of metal. A sledge made of metal. Too much.
You're quite
You'd
pretty.
Too much friction.
You'd never get started. Cheese and crackers. I found it quite difficult to find a citation for this.
Yeah.
But it's roughly 60% of what you need.
Almost spot on.
I guess it depends on the cheese.
Running around to an answer that might work.
Mm-hmm.
Rubber soles of a shoe
Yep.
on carpet is between 80%
Just
and
the way God
100%
intended it.
of the friction you need.
So you could stand up at the top of Everest, a carpet Everest, and just someone push you and you're, wee.
Essentially, if
But
you
then
could
it
keep
just
balance
continue
enough.
going at around the same speed.
Yeah.
So you just hit. So you want to hit the ground at the speed you want to be going at the whole way down, and then like, you just stay at that speed.
Essentially.
Pretty much. So
Should we look?
in order for it to be thrilling, you have to be thrilled by the idea of going at the same speed all the way down for a really long time.
Just have a really.
You could perhaps control your speed by lifting up certain parts of the.
Yes.
Now, you might ask.
Pretty views.
You might ask.
Yeah.
How would I possibly know that the coefficient of friction between shoes and a carpet is the right amount?
Yes.
Well, there is a very lengthy paper called The Slipperiness and Coefficient of Friction on Carpets. Some 30 or 40 pages long.
Mm-hmm.
And it gives a full description of which rubber soles of which shoes and which different piles of carpets give the right amount of friction. So you could actually just pick your Mount Everest to be made out of a certain pile of carpet that you like. No comment, of course, on the underlay.
James, have you got a question for us, sir?
Okay, so you know how there's like a load of stuff on the world, and you know how like things like hit the world, like meteorites and stuff, and then we keep sending stuff into space, like satellites. Well, is the amount of stuff on Earth increasing, decreasing, or staying the same?
Decreasing?
Yeah, so like, are we sending more stuff into space than like is coming in, or maybe like stuff just leaves the atmosphere? Maybe like gases kind of just like bugger off into space. I don't know how it works.
Because I guess the only new stuff we get is like meteorites, right? Things
Correct.
like burning up and landing on the ground from
Paul.
space.
Does the amount of stuff in your house increase, decrease, or stay the same?
Increase.
Why?
Because there is an innate desire to hoard.
This can't go on, Paul.
No,
This can't go on forever.
it shouldn't. I barely got here today.
Because you had to rummage your way through
Yeah,
your own house.
yeah.
But you reckon there's an innate desire to hoard? You reckon just people just naturally want to keep things?
I think
get
it's built
memories.
into society as well.
Yeah.
Of having stuff so you can show other people that you have more stuff. I think that's built into everyone.
It's quite bizarre, though, isn't it? Because, our ancestors, hunter-gatherers, would have just had nothing. It would have had, like,
So
a couple of tools,
yeah.
maybe.
I would have thought like prototypic humans would be quite detached from owning things because obviously Matthew said they were hunter-gatherers, so they wanted to move around a lot. So having stuff would be quite cumbersome.
Surely you'd have your own specialised hunting tools, though, that would be like your prized
I don't
possession.
know. I think you would
that
just
you've
get
made.
really good at making them like on the fly.
Interesting.
Surely it would be more efficient time-wise, though, if you perfected a nice, look at my piece of flint. It's so sharp, I made it really sharp. And then you can get the animals.
Get them.
Yeah,
Get
for,
them.
for your food,
What is
For your
getting them?
clothes, stabbing them with your flint.
What about useless stuff like necklaces or jewelry in ancient humans? As soon as they had enough time to not spend the entire time hunting and gathering, they could show off their perceived wealth by having stuff that didn't have a use.
I guess that's the ultimate show of wealth, isn't it? The more pointless things you have.
Do you think animals, like other animals apart from us, enjoy that as well? Because, you always see American golden retrievers always have neckerchiefs.
Mm.
They definitely put them on themselves.
No, I
Yeah,
think
but no,
isn't that to keep off the dust when they're chasing cows? Riding horses around
The dogs. Wait, what? Are we talking about the same thing? Nope. This is a joke,
Do you guys
wasn't
know what a dog is?
classic
so-
rules.
Surely a classic hoarding animal are magpies, right? Keeping whole nests full of shiny things.
Exactly.
Basically what I do.
And is it bowerbirds, those ones who build the unbelievably complicated...
Yeah, and they like
Mass.
choose specific colours, don't they? So there's a really good Attenborough clip where this bowerbird goes on and just steals loads of blue stuff from everywhere, and it's just got the best blue nest ever.
So pretty.
And all the ladybirds are like, yeah.
And
Not
they
ladybirds as in the insects, as in like
The one as well where they
ladybirds.
do the it does the special dance. He like almost makes a little arena for himself
Yeah,
to
yeah,
perform
like
in,
raises
little
its wings up into
flowers.
like an umbrella shape and goes. I'm actually dancing, but
Yeah.
that's the noise you make. This is all like great, but all of this stuff is and will always be on Earth, so it's kind of not approaching my question.
How about this? Since we started the Industrial Revolution, we have both taken what's essentially rocks, fossil fuels, out of the Earth and burnt them and turned them into gas, so they're no longer on the Earth. We've also been creating aeroplanes, many of which are not at any one time in contact with the Earth.
I don't know. I was thinking with the Earth, though, I was thinking like anything within the atmosphere. This is your question, right, James?
Mhm.
What do you mean by on the Earth?
Where does the atmosphere stop?
I think it's like 12 kilometers above the ground, I think, or something like that. But I don't know. I would say my first thought was literally on the ground, so connected to the ground. But that's kind of an unsatisfactory answer for Earth. So let's say within the effective atmosphere.
Effective atmosphere.
Effective atmosphere. Yeah.
So, space stuff disappearing from the Earth. Has anyone got an answer? I do.
Oh well, there we go. Come on.
So, someone was mentioning stuff about meteorites, stuff
Hello.
hitting the world. I've done this whole answer on the basis that anything within the atmosphere still counts as being on the Earth. So every single day, the Earth gains about how many tons do you reckon of space debris worth of extra matter just coming in?
1/10 of a ton.
3 tons.
250
Tons?
Yeah, about 250
What?
tons
Give me that
Where does
double
it
decker
go?
buses.
slapped onto the Earth.
So wait, what is this space debris in the form of? Is it like very small, teeny weeny rocks?
Dust, rocks, anything coming in from space. I recalculated the number rather than 250 tons.
Right.
There's about 500 horses.
Okay.
Is that reasonable? A
That's
horse is like half a ton.
the SI unit of space waste, isn't it?
How do they estimate that? Oh, do you take like a little sample of like the desert and be like, oh, this bit's from space. It's probably this much all over the Earth.
I don't know.
Could you have like, if you had a probe at the like limit of the atmosphere and you measured the amount of like stuff hitting it and you said that's like the surface area of that probe and then just multiplied that by?
Yeah, so of the matter in space, it's something like less than 10% is stuff that we see as stars and planets and things. Most of it is just a load of dust and just little bits floating about.
Wow.
So yeah, we gain about 250 tons every day of kind of space debris. And then obviously we kind of create a bit of space debris ourselves that go in an outward direction, and then we send up like a few satellites and things like that. Does that count as leaving the Earth or not? I didn't really make a decision on that because it's actually kind of negligible. It's like a really, really small amount overall. But every single day we also lose about 250 tons from helium and hydrogen in the upper atmosphere, just kind of drifting away. So yeah, there is like a really a projected shortage of helium. We think we're gonna run out in not too big a period of time, which is why the Americans are stockpiling that enormous big reservoir of heliums. But it's really cool how it's so the numbers are so close. Like year to year, some years the Earth will slightly lose mass, and some years it will slightly gain mass, depending on how much space debris comes in. Because we consistently lose about 250, 260 tons per day of the helium and the hydrogen.
Wow, that's a lot of gas to lose, though, isn't it? Yeah.
Why would it be an issue if we lost all the helium, if we ran out of helium on the planet?
Because we use liquid helium for creating like super powerful magnets and stuff. Like, you know this stuff, Paul.
And balloons.
It's a leading question.
If you
Imagine
lose,
the parties without helium. It'd be terrible.
I might be like kind of interrupting your fact, but like this is just speculative. But if you're losing gas but you're gaining solid on Earth, does that mean that the pressure on Earth is going down over time? If you're losing the amount of stuff that's in this gaseous form in the atmosphere, then you have like fewer particles in the air or molecules in the air filling the same space.
Yeah, but things are being converted to gases, like Paul said. You know, like we're burning a lot more things now than we were previously.
So probably nobody's looked this up, but is the air pressure on Earth changing over time then?
The pressure at ground level, at sea level, will be fixed by the gravitational pull of the Earth, not how much gas there is above it.
Wow, that's cool.
Does anyone know the difference between a meteor and a meteorite?
One
Meteorite's one that
has landed.
gets through, yeah.
And a meteor is?
One that doesn't.
Just
one that burns
burns up.
Interesting.
So, but that still counts within this question as being part of the Earth, right?
Because you'd still get it in your atmosphere. Even though
Still
it's
in the
burnt
atmosphere.
up, you'd get the constituent parts.
So I found out something
Yeah.
which I don't think you're going to believe,
I'm not going to believe it.
which is that a meteor actually describes the flash of light that you see as it's burning up in the atmosphere. What's burning up in the atmosphere, you ask? A meteoroid
A
There we
meteoroid.
go.
is the actual debris. A meteor is a flash, and if it hits the Earth, it's a meteorite.
Well, you're correct. Don't believe it. I refuse to believe it. Anyway, going back to my answer. Keeps being interrupted. It's fine. I like the interruptions. So yeah, no, I thought it was quite cool about how it's such a close coincidence in terms of mass that we're losing and mass that we're gaining, and it kind of reminded me of how the moon and the sun are almost exactly the same size in terms of our perception of them in the sky, which is a really big coincidence, which obviously has had huge consequences for mythology because people have always thought of the moon and the sun as being equivalent objects when we know that they're actually very different in size.
It's one of the cool things as well with the moon and the sun, right, is that the moon is 1/400th the size or the radius of the sun, but it's also 400 times closer. And that's why we get total eclipses. And that's why they match up so perfectly, is because it's this wonderful ratio that we're living in a very specific time. People in the future will not get proper eclipses like we do. The moon's going away.
These are the days, right? They're going to look back and be like,
yeah.
those were the days. The other thing as well is obviously in the center of the Earth, there's a bit of a radioactive decay going on, which means that you've got mass converting itself to energy. But that's only a really small loss. That means that we lose about 0.05 tons per day. So it's kind of completely irrelevant compared to the other stuff. But do you guys know how much mass, or how quickly the sun is losing mass? Because obviously it's converting loads of its mass into energy through through radioactive processes.
Fusion. No, I don't know how much.
Loses about 5.5 million tons every single second.
Wow.
How heavy is the sun? For context, any idea?
A little bit
One
heavy.
solar
Little bit heavy.
mass.
So yeah, that was it. Actually, had some other things to say, but I'll save them for another time.
So your answer is staying the same, basically.
Yeah.
That's
Essentially,
re-
it stays,
I did not
stays about
expect
the same.
that. I thought it was clearly going to be. Actually, what did I think it was clearly going to be? Going up. I thought it was clearly going to be going up because
Going
like
up,
stuff
going
gets
up.
trapped in orbit, but nothing. We don't send that much out in space, so quite surprised. Thanks, Matthew.
I welcome your surprise, James.
And now for the mystery midsection. Just before we started the show, I gave everyone the following question.
It has been proposed that the gene VM82 does what?
I then asked everyone to write down a fictional but reasonable sounding answer. I will now read out all of those answers with the real answer mixed in. Everyone will then get a chance to decide which answer they think is right. VM82 determines your charm capabilities. More VM82, more charming. Prince Charming has 100% VM82 genes. It has been found to be associated with the tendency to be more spiritual. People with a certain type of VM82 tend to be more open to mystical experiences. It is the gene that makes mango, for some 10% of the population, taste like rotting fish. Following the critical acclaim and genre-defining work of VM81, the sequel VM82 is sure to leave every viewer drowning in the sense that life is without purpose, death is absolute, and that happiness is only an illusion, sustained by continuous escapism. 4 stars. VM82 has been referred to as the video game gene. Professional gamers have been found to have a higher expression of VM82 gene products.
The mango one sounds kind of plausible because there are people with that coriander gene which tastes soapy. Although maybe that means that it's maybe a lie.
I know my brother-in-law thinks that mango tastes like rotting fish.
What?
How many brothers-in-laws do you have? 10. So just one.
I can't.
One in 10.
Yeah, exactly. Quite. Yeah, there's one in every 10.
Yeah, 10% seems pretty high. Mango
Yeah.
rotting fish, especially considering mango is, as everybody knows, the most delicious flavour that exists.
Well, 9 out of 10 people think so.
Yeah.
And some of the people who really like the taste of rotting fish.
Oh, yes, of course.
But it's just easier to get it in mango form.
Surströmming thing, the Swedish fermented fish thing.
Oh no,
Oh my
the
God.
one that you're not allowed to open in confined spaces.
Tastes like mango, right?
No, it's really good with mango chutney.
Nice.
Um,
Right, Matthew, what do you reckon? Go on. Got to press you for an answer.
we've got to press on,
Yeah,
haven't
we've got
we?
to press on.
Right, for the last one, I just wrote down VM82 as my reminder of what it was. So can you remind me what
That was
last
the
one
video
was?
game
the
gene.
video
Oh,
game
the video
gene.
gaming one. Quite like the video gaming one because the mango percentage does seem a bit high.
Maybe there just aren't that many people that eat mangoes as you expect. Maybe it's a preference thing. Maybe it.
Why are you guys both supporting the mango answer?
I don't know mangoes. I don't know any
know
mangoes
mangoes.
personally. They're all lovely feathers
I
from
know a
what
lot
I've
of
heard.
mangoes. Okay, so do you want to go for video game gene? So I just want to keep the show moving along, you know.
All right, I'll go for video game.
Oh, Josie, come on, stay in turn, please, please. Matthew.
I would like to go for mango.
Okay, 1 for mango. Josie, video game.
Games, yeah.
1 for video game.
Oh no, he's
Paul.
smiling. It's Paul's
I
one,
hate
isn't
to
it?
order the same thing off the menu twice, but I think video games.
Oh, crap.
Okay.
It's video games.
So we've had
Paul
2
did
for
the
video
mango
games
thing.
and
Look at him.
so just to reveal what's happened is I've pulled a blinder and
No.
gathered all but 1 point because I made up the video game gene one.
Wow.
And who was the mango one?
Me.
It was
Me.
Paul.
That was good. That was very plausible.
Yeah, that was very good.
Thank
that
you.
was very well played. Paul
Incidentally, my brother-in-law does actually
Yeah.
think that...
10% is pretty high, though.
Yeah.
Well, it's
Nearly-
100% of brother-in-laws.
You nearly shook me off there.
So on average of all brother-in-laws, 10%. So the correct answer was
Was the
actually
spiritual
one. Correct?
No
yeah.
way.
So this is a little bit controversial and it was maybe a bit of a cheeky question to ask you, but there's a geneticist who wrote a book called The God Gene. And basically, they did this kind of study of human spirituality. So you ask people questions like, do you believe in mystical experiences?
Nope.
Do you have... Okay, Matthew's got a no on that one. Are you self-forgetful? So self-forgetfulness being, if you read a fictional book or watch a movie, do you kind of detach yourself from reality and place yourself in that fictional world? Another criteria is transpersonal identification. So how much do you identify with the universe as a whole, and again, like detach yourself from being an individual and identify with the universe? And yeah, and this idea of mysticism. So are you open to the idea of things like ghosts and communicating with the dead and stuff? And they found that, at least in this one study, they found that people with an expression of this VMAT2 gene were associated with having higher scores on these spirituality scales. I think it's, in the kind of wider geneticist community, people are like, well, it's not saying that this gene is associated, it's not the kind of end all or be all of spirituality, but there is strong evidence that there's a genetic component to spirituality. So in twin studies, people that are raised separately, you can attribute a lot of the variance in kind of how much affinity you have for spiritual phenomena to be down to genetics rather than your upbringing.
Why is connectivity to the universe considered a spiritual thing?
I guess it's just like the idea that there's kind of powers and like phenomena in the universe that are outside of humanity that kind of transcend our reality.
Yeah.
Yeah, because that's like not your immediate surroundings.
Yeah, so it's the idea of, it's like the idea of heaven, right, is kind of like transpersonal, like, it's kind of transcendental. It's
I
like
guess
in a different plane.
horoscopes too, right? That counts as being influenced by the planets when we're not.
But there is actually some science behind this. So this VMAT2 gene codes for vesicular monoamine transporter 2, which is basically a neurotransmitter transporter. So it's related to things like serotonin, dopamine, etc. So people who are deficient in a VMAT2, there's a link between that deficiency and schizophrenia. So people with increased subcortical dopamine, which leads to psychosis, are more likely to be schizophrenic, and is related to these sorts of gene products. And that people kind of posited that the evolutionary advantage to being spiritual is that it gives people a kind of innate sense of optimism. So you're more likely to kind of go on living through all the hardship. So there you go. So maybe there is some kind of advantage in evolution to being spiritual.
I read somewhere as well that if you're creative, you're more likely to be spiritual or into something that is spiritual too.
There was an experiment where someone stimulated a certain part of the brain while people were in an otherwise dark and silent room. And the people whose brain was stimulated, when asked afterwards, they said that they thought that there was someone else in the room, but they weren't worried about it, despite the fact they couldn't see them or didn't know who they were. They felt quite calm. It was nice, a nice presence, and they were just happier that there was someone else in the room with them and would be there for them. And the people who didn't get their brain stimulated had no such feelings. And this is linking back to this idea that we might have evolved because if we think that there's something greater, then it might be an evolutionary advantageous tactic.
Very nice. So not Prince Charming then. Well, they're not so far.
And I also reckon there probably is a video game gene out there just waiting to be found.
I've got a question. Who or what is the most important animal in the world?
The first one.
The first animal. As in like the most recent common ancestor of all animals. And yeah, I suppose that's pretty important. So
Job done.
Yeah, job done. I don't reckon it is.
There we go. That was a quick one.
I know what it is. It's the snake from Adam and Eve.
Ah.
No snake, no people.
No knowledge.
No humans.
No fun.
People. No fun, definitely. No knowledge. Isn't that the thing?
No knowledge,
Yeah,
that'd
it's
be
all
rubbish. I never understand why the snake's seen as a bad thing.
just from God's.
No crime in trying to have a good time, is there?
What about bees?
Oh, it's always bees, isn't it?
I know.
It's always comes
Wait,
back
or-
to bees.
Or plankton.
Yeah.
There's a lot of plankton in the sea. They're important for oxygen.
Yeah. Why do you reckon bees?
They seem to do a pretty good job of pollinating.
Yeah.
I don't know whether it's just flowers and it's just pretty, but if it's vegetation that we rely on or that other animals rely on, then they seem pretty important. I'm going to go on a strange but fun tangent here and say that bees have another very important use. So the agency that looks after our atomic weapons, they do tests around the country to check that they have a acceptable level of nuclear fallout from the lab. And the way they would do this is to sample wildlife around the country. to check that it hasn't got the evidence of nuclear contamination. But then they realised that there's something else going around the country and sampling vegetation, and they actually just go into each county and check the honey, and the bees do the sampling for them. And it's restricted the amount of time that they have to do it. No end.
Bees are absolute heroes.
They really are.
I'm going to see your bees, and I'm going to raise you the Greenland shark.
Oh, tell me more.
Come now, what is it?
The Greenland shark.
It's a shark, mate.
It's a shark.
From
Is it a green
Greenland.
shark?
It's got a big
Or it's from
green
Greenland.
bit of land on its
Greenland
back.
sharks
Just a
live
little bit of moss.
Yeah, just a wee
long.
bit.
I think they're the oldest living vertebrate. So far, we think they live about 400-ish years.
Wow.
We don't know exactly, but part of the idea is that for
What a
some
birthday cake.
reason, staying in adolescence longer, or staying as a child longer, allows for a much longer lifespan. So many Greenland sharks don't actually reach sexual maturity until they're like above 100 years old,
Wow.
which is obviously fine within the context of like a slow-moving planet where the oceans aren't constantly being destroyed. But nowadays, the Greenland sharks are obviously really struggling because if they get killed before they reach breeding age, then they can't.
They're just
So-
out partying and making bad decisions.
So is that called neoteny, right? I think it's neoteny.
You know all
so,
the technical
So I
words,
think so pedomorphism is where an animal kind of like changes its life cycle so that it spends longer in the like juvenile form.
Ah, cool.
And I think I think pedomorphism is becoming more like your juvenile form,
So
whereas
that's like the
neoteny is
jellyfish that turns that back into a polyps.
yeah, could
back
be.
into a little
I'm not
baby.
aware of that one, but yeah.
That's-
I think we call this neoteny, the idea of like prolonging your juvenile life stage. So
Come on,
sharks
Mr.
are
Shark.
really important, actually, because they use so there's two animals that are really important as indicators of the ecosystem. So one is sharks. So if sharks are healthy in like an area of ocean, then you're pretty confident your ocean's healthy. And frogs are a really good indicator for land environments because they're so sensitive to like changes in the environment. So if all your frogs are dying or like unhealthy, then you can be pretty sure your ecosystem's a bit buggered.
On an
Oh.
island last week, there were so many frogs about, and it just
Yeah.
felt the ecosystem just felt really healthy.
It felt really vibrant.
It felt healthy and vibrant, James.
What,
just-
what
Green and fresh.
what sound does a frog make?
Sorry?
What sound does a frog make?
Doesn't it just say its own name like a Pokemon?
Someone give me the obvious wrong answer here.
Nobody's gonna take
not
the bait,
doing it,
mate.
Paul.
Come on.
Yeah.
Who do you think we are?
Yeah. Well,
Right.
I mean,
Well, let's move on.
the frogs are all a bit.
Thank you. Why does it make that sound?
it's got a frog in its throat. Huh.
I will second Josie's answer.
All right. Why does everyone think that frogs make a ribbit sound? In the same way that dogs say woof and cats say meow, why is ribbit the sound that humans have been taught frogs make? And the answer is,
Yeah.
there is one species of frog that makes a ribbit sound, one and only one,
Yeah.
and it lives in Hollywood. So when they sampled a frog sound and used
that's
it in the films of the golden era, whenever there was a jungle or anywhere they needed to sound
It's always that.
built up, non-urban, they used a sample from the frog sound from Hollywood, and everyone
Ooh.
believes that was what sound of frogs make.
What's the most important animal?
Well, I want to continue my case for the Greenland shark.
Despite
not gonna
evidence to the
end.
contrary.
Yeah, no, I don't have much else apart from that they have like this bioluminescent crustacean thing that attaches itself around their eyes.
Oh,
So
yeah.
their
Me
eyes
too.
are a
That
bit
sounds
glowy.
very crucial.
Cool. It's cool, isn't it? Yeah. It's like a makeup. Carry
All the
on.
lady sharks.
I'm willing to accept that it might not be the Greenland shark, but who's got something?
Mm.
Someone researched a little.
I mean, so this is a huge question because obviously there are a lot of animals. So there's two routes we can go down. Which is the individual animal that's the most important? Because there are a lot of big name animals in the world.
Mm.
We talked about the snake in Adam and Eve. I think it's very big. So I thought maybe one of the most important animals is the. Do you guys know about lolcats? So like the original internet meme.
Yeah.
So do you remember I Can Hash Cheeseburger? I think the cat in the first lolcat, the first I Can Hash Cheeseburger picture, is pretty important. There are other notable cats. I mean, it always seems to be cats because people seem to love cats. Actually, the first cat meme, 1870. There's a guy who just dressed up a cat and took loads of pictures of it. And this is
and then waited 120 years to post them online.
exactly. Yeah, I know there will be a format for this soon. Some other. It's like Niels the penguin. Is a colonel in chief in the Norwegian army.
Mm.
Chesty, a marine bulldog in the U.S. Marines. He's a sergeant major. But anyway, these are individuals, and all silly, and only important to humans. So I want to think about what's important to life as a whole. And often we'll probably become quite human-centric in this, but I think we've talked about a lot of the animals. So I'm going to list a few animals, then I'm going to give them an arbitrary number, an arbitrary score, and then at the end we can decide which is the most important. So, okay, bees. Talks about bees, pretty important. Big in the news, neonicotinoids and pesticides. Big problem for the bees.
I've just been watching the battle between the Monsanto and Bayer. Those are the people who are making the neonics, isn't it? I think so. I think it's the conglomerate that's making the neonics, which are obviously really bad for the bees, and they keep lobbying the EU, and the EU's like, no, it's really obvious that we should have these things banned, but they keep pouring money into trying to get them unbanned.
So yeah, bees are quite important because obviously they're responsible for pollination. They pollinate 1/6 of all flowering plants in the world, apparently. So that's quite important. A third of our food is pollination dependent. So you do the math because I'm not gonna.
I probably won't either, actually. I'll take you.
We'll leave it to the imagination because that's how math should be, an imagination-based game.
Yeah, famously.
Famously, yeah.
Imaginary numbers.
So bees, just based on the fact that they're pollinators, I'm going to give a score of 2. Yeah. Okay, so plankton. Talks about plankton, but plankton's not actually animals. Plankton is just referring to all the stuff in the ocean that doesn't move around on its own. So this has got like algae, krill, lots of bacteria, lots of viruses. As a whole, really important, half of the world's oxygen comes from plankton.
Wow.
So if there was no plankton...
So you do the maths,
You
Paul.
do the maths. Again, Paul.
imagine.
Come on, Paul. If we no plankton, very little oxygen, so probably wouldn't have as much life. Probably some would still be okay. So I'm going to give plankton a half a point.
Plankton would probably be fine.
The plankton would be fine, yeah.
If it just sacked it off.
So I'm going to give plankton half a point because only, it's not completely an animal. Fungi, not animals either, but so this is a bit of a tangent, but really interesting because fungi are actually more related to animals than they are to plants, which I was quite surprised by because they are eukaryotes.
Shocked and appalled.
Shocked and appalled, I mean.
We've not got
there's a
much room
Paul
for
here.
facts like that here.
Disgusted and consumed with rage.
You're shocked and appalled. I'm weary and a-jamesed.
We're all fun guys to hang around with, aren't we? Yeah, good. Somebody had to do it. Right. So, okay. Anyway, the reason I think they're important is because the first plants to colonize land relied on fungi. In fact, 70% of plants now rely on fungi to extract nutrients from soil. So there's a type of fungi called arbuscular mycorrhizal fungi, and these basically form colonies within the cells of root systems on plants, and they allow plants to extract nutrients. So without fungi, there would be no land plants and therefore probably no life on land. So
Legends.
Wow.
pretty important. So I give them a score of actually 0 because there's the non-animal multiplier, which, of course, gives them a score of 0. Ants, talk about ants a lot, pretty important. They basically, they turn up soil and they get rid of pests. So crops that have ants present in them have much higher crop yields. So 36% higher crop yields when there's ants present.
Wow.
So ants are pretty important. Oh, I haven't scored ants. Going to give ants 0.1.
Carry on.
I'm struggling with this scale, but we'll move on.
0.1. So ants are really important, but there's so many ants that they obviously get a divider. So divide by the number of ants, that's 0.1.
Okay.
Obviously, yeah. Okay, so basically there's loads of like really small animals, insects in particular, fungi, plankton, that all seem really important. So I was thinking, well, I can't really choose one of them. So I started looking at like the ecology of like animals, and you come across this idea of food webs and trophic cascades. And these are basically the idea that, we all learn about food chains in school, but actually the reality is that there is no real food chain. All these different trophic levels, so from like plankton through to insects, through to fish, through to mammals, there's lots and lots of connections like throughout these trophic levels. Because
trophic level is like an energy level, right?
Yeah, so it's an energy level.
stored in
So
a living thing.
the closer you are to kind of, being a producer, so maybe being a plant, you're like a lower trophic level. Apex predators would be the highest trophic level. And what this means is that if you remove an animal from anywhere in the food web, the environment suffers as a result. So there's some really famous examples. You guys might have heard of the wolves in Yellowstone. Okay, so basically, wolves used to be abundant in Yellowstone, but then they started dying out. And what happened as a result was that all the elk in Yellowstone, their population took off massively. And also what they did, the elk, because they had no predators, they used to just stay in the same place and eat all the saplings in one place. And what this meant was that all the beavers who relied on those saplings for their food source didn't have any food anymore. So the beavers died out. And because the beavers died out, all the dams disappeared. And because all the dams disappeared, the water level and the river systems in Yellowstone all just collapsed. And so basically you started seeing things like drought and like plants dying out. So what they did in 1995 is they reintroduced wolves into Yellowstone. And they went from having one beaver colony in the park to 9. And all the elk population went down. And the dams came back, and suddenly, like, all of the food web just improved drastically.
The river like literally changed shape. You can see it over like a short number of years.
Literally changed it. Yeah.
Why did the wolves leave in the first place?
Human
influence.
It's always human influence, isn't it? Yeah. So it's really interesting, like this idea of a food web, and if you deplete certain parts of the food web, you have a big impact on other levels. And the last point I just want to make is that, you know, a bit of a plug for human impact on the environment. So trophic levels in fish systems are really interesting. Okay, so historically we always fish fish that are high up on the trophic scale, so things like tuna, cod, swordfish. So these are like big apex predators in the ocean. But over time, because we've overfished these populations, we've had to resort to going further down the trophic scale. So now we fish more like herrings and sardines and anchovies. And they now use this mean fish trophic level as an indicator of how healthy the marine environment is. So we've seen actually a mean drop in trophic level being fished between 0.5 and 1 in the past 50 years, which basically means we're absolutely screwing over the top apex predators.
So we're not only like overfishing, but we're taking away all of the food for the top fish that we want to fish.
Yeah, so now we're just moving down and we're kind of, you know, overexploiting each level.
Does anyone know why lobsters are a foot long?
Exactly a foot.
Well, when you see a lobster, it's approximately a foot long.
Why?
Because there is a law against harvesting infant lobsters, and the age at which you are allowed to harvest them makes them exactly or approximately that length.
All right.
Lobsters don't actually stop growing. So back in the good old days, when lobsters weren't a delicacy and were thought of as bottom feeders and quite a cheap food, they would be absolutely enormous, several feet at least. And now it's so unusual to find those, because if you catch a small lobster and it's too young, you throw it back in and it'll get caught eventually. I think it's 18 months or something like that. That's the
I wonder if
age.
there's one lobster that's just hiding somewhere that's absolutely gargantuan.
He started hiding under a little shell and he hasn't moved, and now he's just completely delusional. 3 feet long, 6 feet long under this tiny little shell.
Classic. And we have arrived at the end. Points have been allocated by our producer, Sam Lee, according to a system that none of us understands. Sam, what's the verdict?
Well, firstly, well done, team, for braving it up into the death zone to the summit of Mount Everest, from which we've all since been sliding down for the duration of this, if I'm honest, logistical nightmare of a podcast recording. But nevertheless, I can reveal who made it down in the fastest time, based on the materials you each chose to brave the slopes on. James and Matthew. Your slippery, soup-slicked sandals were an inventive effort, but barely got you down to base camp, I'm afraid.
Rough ride.
Paul maintained a speedy yet steady pace all the way down and into the bank of mattresses waiting at the bottom, thanks to some lovingly lubricated linoleum-laminated loafers. But it was Josie, with your friction-free footwear fashioned from a frying pan. It's your Teflon-treated toes that won you the race today. Congrats on winning this week's high-speed mountainside podcast.
For now, thanks to Josie Peters,
Thank you.
Paul Stubley,
You're welcome.
James Hay,
Cheers.
Matthew Shribman, that's me, our producer Sam Lee, and to Unbound for their generosity in hosting and supporting us. You can follow us on social media by searching A Piece of String or String Podcast.
If you would like to find out more about astronomy and astrophysics, you can follow me personally on Twitter and YouTube at Josie A. Peters.
And if you'd like to learn about many and various scientific curiosities from a man in a bath, or otherwise located, you can follow me on social media by searching Science in the Bath or Matthew Shribman.
If you have a quirky question of your own that you'd like a scientific answer for, then please reach out to us on any of our social media channels.
Thanks for listening. Please rate and review us on Spotify and iTunes and Stitcher and so on. It makes a really big difference in spreading the word. We'll be back again in a fortnight, and as usual, let's never speak of any of this ever again.